Okay, so solve natin yung problem na to. A reinforced concrete column 5 meter high has a cross section of 400 by 400 mm. Okay, so it is reinforced by 4 steel bars, each 20 millimeter in diameter, and carries a load of 1,000 kilonewton. So ito yung actual load na pinapasan ng column natin, no? So yung Young modulus for steel bar is 200,000 megapascal, and that for concrete is 15,000 megapascal. So neglect lang natin yung concrete displays or yung holes, no? For example, yung meaning dito is since may bakal ka na in-embed dun sa concrete, so supposedly dapat walang concrete dun, no? So i-neglect lang natin yun, no? So like assume na neglected lang yung mga concrete holes. Okay, so determine yung mga stresses in steel and in concrete, and also determine the shortening ng column. Okay, so bali yung column natin is meron siyang 5 meter high. So bali to solve for this one, so meron tayong dalawang titignan, no? The first one is with regards to stress or yung forces, and the other one is for deformation. Anyway, tingnan ko lang to. So bali yung column natin is meron tayong ganito. So itong 5 meter high na column na to, so pinapasan niya ngayon yung load applied natin, which is itong 1,000 kilonewton, no? So we know na itong reinforced concrete na column na to is meron tong concrete, at the same time meron siyang steel, no? Which is embedded dun sa loob nung column natin. So meaning yung dalawang material na yun magre-resist yan, no? So bali meron tayo ditong force sa concrete, at the same time meron tayong force caused by steel bar. Okay, so bali yung key equation natin dito is summation of forces vertical equal to 0. So meron tayong P ni concrete plus P ni steel, which is equivalent to 1,000 kilonewton. Okay? Okay. So another key equation na pwede natin magamit dito is ito, no? So ito yung reinforced concrete column natin. Ngayon may in-apply tayo dito na load, no? With respect naman sa deformation, so ito yung equilibrium equation natin, di ba? So di kaya computein yung mga forces ng concrete tsaka yung steel by equilibrium equation alone, no? So we need help for deformation. So itong reinforced concrete na to, meron tong concrete tsaka yung steel which is embedded sa kanila. So meaning may displacement na mangyayari dito, no? Which is kung ito yung original level ng column natin, so probably yung displacement nito is ganito, no? So like meron siyang displacement sa concrete, di ba? Which is also equivalent sa displacement ng steel bar. Okay? So kasi naka-embed yung steel bar sa loob ng concrete column natin. So yan yung magiging key equation natin. So that is deflection ng concrete, which is equivalent to deflection ng steel. So we know that deflection is four levers are everywhere. So we have force ni concrete, length ni concrete, tsaka yung area, cross-sectional area ni concrete, elastic modulus ni concrete, no? Which is equivalent to force ni steel, length ni steel, cross-sectional area of steel, and the elastic modulus of steel. So, yung length ng concrete tsaka yung length ng steel, the same, no? So, bali ito is cancel out, no? So, yung matitira na lang dito is we have force ni concrete all over yung cross-sectional area ni concrete tsaka yung elastic modulus ni concrete, which is equivalent sa P ni steel, area of steel, and E ni steel. Thus, yung substitute natin yung value dito, or if you want to compute for force ni steel, that is just area ni steel over area ni concrete, elastic modulus of steel over elastic modulus of concrete multiplied by P concrete, di ba? So, yung area ni steel is we have apat na bakal daw. Apat na tag 20 mm diameter. So, meron tayong apat na pi over 4, 20 mm. And for reinforced concrete, so since i-click lang natin yung concrete holes, so parang conservative na analysis to. So, let's say we have 400 mm by 400 mm. Next is for the Young modulus, no? So, we have for steel 200,000, and for concrete we have 15,000. This is given. So thus we have P ni steel in function of P ni concrete. So if you use our calculator, so we have for a while computing ko muna saglit, no? So meron akong apat na pi over 4, 20 squared all over 400 squared, 200,000 over 15,000. So I have 0.105 P ni concrete. Okay, so ngayon pwede natin i-substitute yan dito sa equation 1 natin, no? So sabihin natin this is equation 1, and sabihin natin this is equation 2. Okay, so from equation 1, so we have P ni concrete plus P ni steel, which is 0.105 ni P ni concrete. So this is equal to 1,000 kilonewton. So we can now have the value of P ni concrete, which is 904.98 kilonewton, and P ni steel is equivalent to 0.105 of P concrete. So therefore we have 95.023 kilonewton. So ngayon yung tinatanong sa problem is ano daw yung mga stresses dito sa steel and concrete natin. So pasolve na natin yung stresses. So in terms of stresses, so we have stress for concrete, that is again force over area. So this one is for concrete and cross-sectional area of concrete. So we have 904.98 times 1,000 para Newton. Ito lahat. And then yung cross-sectional area ni concrete is we have 400 by 400. So bali yung sagot nito is 5.66 mega Pascal. So ito na yung sagot. Okay? And for steel, we have force ni steel over cross-sectional area of steel. So this is 95.023 times 1,000 para Newton all over yung apat na tinagpay over 4 diameter pi over 4 diameter squared. So we have 75.62 megapascal. So ito na yung sagot. And for deformation, since alam natin na the same lang yung deflection ng dalawa, so pili na lang tayo at isa sa kanila, na. So sabihin natin yung deflection, yung kunin ko is yung sa concrete. So yung force ni concrete, length ni concrete, cross-sectional area of concrete, and elastic modulus of concrete, na. So yung force ni concrete is we have 904.98 times 1,000 multiplied by length. Yung length nito is 5 meters, so para mm that is 5,000. Cross-sectional area 400 times 400, and then yung elastic modulus for concrete is given 15,000. So we have now density, deflection of, or deformation of concrete. So that is equivalent to, so we have 1.89 mm. Okay? So ito na yung sagot. So kaya tignan natin, no? Like kung gusto natin kunin yung deformation ng sa steel, the same pa rin, no? Like P ni steel, length ni steel, area ni steel, and the elastic modulus of steel, no? So we have for force na steel 95.023, so times 1,000 para Newton. Yung length ng steel is again 5 meters, so this is 5,000. Cross-sectional area, meron tayong apat na tinag 20, and then yung elastic modulus is 200,000. So yung value nito is also 1.89 mm. Okay? So pareho lang, no? Kasi pareho lang kasi yung dalawa, no? So deformation ng concrete tsaka steel, the same. Okay? So ito na yung sagot natin. So, bali dito, kung makikita mo, nineglect lang natin yung concrete displace, no? Or yung holes, no? Pero kung i-consider natin yan, so for instance, so what if the problem state na consider concrete displace or concrete holes, no? So bali yung ginawa natin is di ba may reinforced concrete column tayo, and then meron tayong steel bar, no? So ngayon i-consider natin yung concrete holes, no? Kasi yung steel bar, kung tatanggalin natin yan, so meaning hollow yung portion na yun, no? So may concrete holes supposedly dapat dun, di ba? So anyway, if we consider that one, so medyo medyo mas realistic compare nung una, which is medyo conservative, no? Pero I think di ganun kalayo, no? So anyway, if you consider that one, so yung mangyayari lang is the same equation, di ba? Ito pa rin. Kunin ko lang to. Ayan, the same equation 1 and the same deformation, ha? So, sabihin natin, ito pa rin yun. Diba? Yan pa rin yan. Ayan. So, ngayon, dito, ayan. So, yung mangyayari ngayon dito is ganito, no? Galing ko muna to. Ayan. Then, so bali ito, magdideduct tayo dito ng minus 4 na tag pi over 4 20 squared, no? Ayan, di ba? Kasi ito yung gross area and then ito yung area occupied by steel bar, no? So i-deduct natin yan, no? So yung matira is yung sa concrete lang talaga, no? So bali medyo ano to, we consider the concrete holes, no? Concrete displays by those steel bars. So ngayon multiply natin to. Ayan, so bali yung P ng steel dito is equivalent to, computing ko muna saglit. So this becomes, we have 200,000 divide 15,000 and then dito meron akong 4 na tinag pi over 4, diameter 20 squared, and I have 400 squared minus again yung 4 na tinag pi over 4 times 20 squared. So this becomes 0.106 penny concrete. So makikita mo sobrang ang liit nung ano lang, no? Yung difference, like, di ba? Dito. Ano yung difference? 0.001, no? So sobrang liit, no? Anyway, if we continue that one, so bali yung mangyayari ngayon is from equation 1, so meron na tayong ganito, no? Ito yan, copy ko lang. So papalitan ko to ng pino steel, which is 0.106 of penny concrete, which is equivalent to 1,000 kilonewton. So we have penny concrete, that is 1,000 divided by 1.106. So we have 904 point 0.16 kilonewton. Okay? So, yung una is 904.98 na. Ngayon, naging 904.16 na. So, medyo may diferensya na ngayon sa forces, no? Pero, hindi ganun kalaki. So, anyway, sa steel naman, we have 0.106 of penny concrete. So, you multiply it by 0.106 times 904.16. So, this is 95.84 kilonewton. Okay? So, ngayon, yung stress for concrete is we have 904.16 multiplied by 1,000. So, bali naka-newton to. And dito naman, yung area ng concrete is we have 400 by 400 minus yung sa area occupied by steel bar. So, apat na 20 rebars. So, kumpitin natin yan. 904.16 times 10 to the power of 3. And then we have 400 squared minus, meron tayong apat na pi over 4. Diameter is 20. So this one is 5.7 megapascal. So ito na yung sagot. And for steel, so 95.84 times 10 to the power of 3 para Newton. And then meron tayong apat na tag pi over 4, 20 squared. So therefore this is, tunggalin ko lang to. Then palitan ko to by 95.84. So yung sagot dito is 76.27 megapascal. So ito na yung sagot. Okay? So ganyan if we consider the concrete displays. So yung una natin is we neglect the concrete displays or yung concrete holes, no? And in terms of deflection, so for instance, deformation. So kahit saan lang, no? Kasi yung concrete tsaka yung steel, the same, no? So piliin ko na lang yung steel. Kasi mas maliit yung area yung itatype ko na formula. So for steel, yung steel, area ng steel, plastic modulus of steel. So kunin ko lang yung dito. Ito pa rin yun. So papalitan ko lang ng force. Okay, so papalitan ko lang to ng 95.84. So meron na tayong deformation. Okay, so nagdagan ko lang to ng 5,000. And then nagdagan ko to ng 200,000. So sagot dito is 1.9 mm. Okay, so I think that's it, no? So thank you for listening.